In this video, we're going to introduce you to the concept of recursion, um, and we're going to look at recursive functions versus iterative functions. In basically, by definition, a recursive function is a function that calls itself, and an iterative function is a function that does looping through some sort of loops, like a possibly a while statement or a for loop. Um, let's look at an example here. We're going to make a very quick iterative function, and then once we create this iterative function, we're going to replace it with a function that is recursive in nature, and we're going to call this forever, because we're going to do a infinite loop. Okay, so what I'm doing, I'm using the def keyword to define a function, and we're just going to make an infinite loop. We're going to say while true, and then we're never going to set true set it to false. So this thing is going to run forever unless we take some kind of interaction to stop it. Okay, so what we have here is a very simple function that we're using iteration. We're just gonna do a while loop. We do a standard loop in it, and we're gonna basically print hello forever until we actually physically stop it. So that the program will go on forever if untouched. So now let's call it, and to call this function, we just say its name. So let's run this to see what this does. And as you can see, it's going on and on and on. If you look down here, it's just going on and on. We're going to stop it. Okay, so we interrupted it. And basically, that is how we iteratively create a infinite loop. And let's look at how we might do it recursively by calling with having a function call itself. And then once we're done, looking at really basically with these infinite loops, we're going to actually do something that's useful, that solves a real problem. So let's make another function, and we're going to call this forever and ever. And we're going to say print, say hello or hi. We're just going to say hi this time. Make it a little different than our other function. We could put hello and it would be essentially the same when we're through. And we'd call it self here. Okay. So what's going to happen here? We define a function. If we were to call this function, it would print hi, right? And then it would call itself again and print hi and call itself again and again and again and again and again and again and again. And basically run forever. So let's run this one forever and ever. And as you can see, it's doing the same as the other one. It's going to run and run and run until maximum recursion depth reach. Okay. We actually hit the maximum there. I didn't click it off enough. So what happened here is that we ran up until we had a full filled up our stack, and it couldn't handle anymore. um, one of the uses of recursion, and it gets a lot of publicity, is when you have like the Deep Blue, the IBM machine that took on a chess master and beat him. Um, you have you could look at many possibilities and trees of possibilities with recursion. This time we're going to be quicker. We're going to stop it before we hit our capacity. So obviously, with bigger, more firepower, bigger machines, maybe different languages using recursion, we can hit deeper levels of recursion, and be able to look at more things. Which is important for these very large and complex programs. Programs beyond your standard chess program. And if you have some spare time and are really interested in how to use recursion to solve chess problems, there's tons of Python code, Java code out there on GitHub, where people had did that, and that's a kind of a classic use of recursion. The majority of chess programs out there on the internet that you may purchase on your phone or whatever use recursion to basically make a tree of possibilities and determine the best tree of possibilities. And one of the ways that they do the different levels of hard to easy is they look less, follow the less trees for the easier path. So it's a really interesting subject. We're really not going to go into there. You could probably have an entire course just devoted to chess program and recursively figuring out the best patterns to make your choices in chess. But for today, we're gonna solve some a little less complicated. We're going to examine factorials. I'm not sure if you remember from math, and I'm going to keep this in a comment. Okay, so a factorial is basically 5 factorial would basically be 5 times 4. It's going to keep on decreasing, times 3 times 2. So see the pattern here of decreasing, up times 1, and it's really 1 times 1, which is the end one doesn't I guess doesn't matter, but that's what's really happening. It's going down to, it goes 5, 4, 3, 2, 1, and 0, which happens to 0 factorial goes to 1. Like if you remember from whatever math class that you had introduced factorials to you. And what I thought was kind of neat is being able to recursively go through and solve problems like this. Chess, a lot neater. Big example, take a really long time, and like I said, it's almost a course unto itself, using recursion and whatever language you're using, whether it's Python, we're doing here, whether it's Java, C# or whatever. Really interesting, and lots of stuff out on GitHub, a lot of open source you can grab for free and play around with some really intensive recursion if you are interested in it. So we're going to create another function, and this is going to solve this factorial problem. And so we'll call it factorial, and we're going to say if number equals 0, and like up there we talked about 0 factorial, and that's really just a 1. So we have else. So this covers the condition here, okay? And so we set up our else condition, which is going to be most things are coming through. We go return num, which is a number, whatever they sent, you know, if it's 5, 6, 7, whatever times. And here's going to be really neat, because this is where we're just going to call it itself. So it's within there. We're calling the same function again. So we call it num, but we go num minus 1, because you see how it's going to keep on decreasing until eventually we get 0. And when it's 0, it returns a 1 and does, you know, stops calling itself, and, you know, the whole recursive tree ends right there. Okay, so that looks like all we have. You could also do this with problem with iteration. I believe the book has a sample of that in there if you're interested in doing it with loops. So let's get it to do something, and let's do 6 factorial. That sounds good. We're going to do 6 factorial. So we're going to label it here equals. So 6 factorial equals, and then let's use our factorial function that we just made. Call factorial, and let's give it a parameter that it would eventually turn into num, which is going to use locally. But we're going to pass it 6 as the parameter to the function. Okay, let's review our code really quick. We're going to print out 6 factorial equals, then we're going to call the factorial function. It's going to run through here, and until it equals 0, it's just going to call itself again and again, slowly decreasing, and eventually ending our whole our whole recursive process when we finally get down to 0, and it's just going to return a 1. Multiply that by, you know, whatever's here, and you just get itself, because, you know, 1 times anything is just itself. Okay, that looks good. Let's give it a run. Okay, and we get 720. So if you were to have pull up your calculator, and you would run through that 6 times 5 times 4 times 3 times 2 times 1 times 1, you will get 720. And the main thing that we really need to get out of this chapter is the difference between a recursive and iterative. Once again, iterative will use loops to solve a problem if it's an iterative function. If it is a recursive function, it will solve the problem by calling itself. And infinite loop just keeps on calling itself till someone breaks it, or you run out of basically stack memory space, and it ended up halting here. Loops are notorious for causing issues in taking down systems, and so if you're using you're taking up memory space, there's a lot of times there's safeguards like you've seen that happen here, because we were taking up memory doing that, and there's a safeguard put into Python to stop us from doing that. And that's really was a really small chapter and if you want to really know more about it, go out there, GitHub, grab some of these open source chess programs or other recursive Python programs, and you can see some really impressive things. But what we need to really get out of it is that a recursive function is just a function that calls itself.